You raise your right hand to wave at your own reflection. The figure in the glass raises what looks like its left hand back. The mirror never touched left or right. It only ever flipped depth. That sentence probably sounds wrong. You've waved at mirrors your whole life. Everyone agrees on what happens. The mirror swaps left and right automatically, obviously no different from an observable fact about the glass itself. Here's the test that breaks that explanation completely using nothing but your own body. Stand in front of a mirror right now, or picture doing it. Tilt your head 90 degrees so you're lying sideways relative to your reflection. If the mirror really does swap left and right as a fixed rule, tilting your head should swap something else instead. Up and down should flip. Your reflection's head should now appear where its feet used to be. It doesn't. Your reflection's head stays exactly where your head is. Its feet stay exactly where your feet are. No matter how you rotate, tilt, or spin in front of the glass, up stays up and down stays down in the reflection every single time. That's strange if the mirror is really performing some kind of left-right specific operation. A rule that only swaps one particular pair of directions, but somehow ignores an identical pair rotated 90 degrees, isn't describing anything about the mirror at all. Something else is going on, and it has nothing to do with sideways. A mirror is a flat surface, and it follows exactly one geometric rule. Light hits the surface and bounces back along the axis perpendicular to that surface. That's it. That's the entire physics. The mirror reverses depth, the front-to-back direction, the axis running straight into the glass and straight back out. It does not touch up-down, it does not touch left-right. It touches one single axis uniformly regardless of how you're oriented when you stand in front of it. Picture a rubber stamp pressed onto a page. The image that comes out is reversed compared to the stamp's face, not because left and right got specifically swapped, but because the entire stamp got pressed through one flip front to back. Ink that was facing you on the stamp now faces the paper. That's the same basic logic driving a mirror, just applied to light instead of ink. So if the mirror only ever flips depth, where does the left-right illusion actually come from? It comes from inside your own head, and not from the glass. To compare yourself with your reflection, your brain does something automatic, something you've never consciously noticed happening. It imagines that the figure facing you has physically turned around, rotating 180 degrees on a vertical axis the way a real person would if they walked around to stand facing you directly. That's exactly what would happen if a friend walked around to face you. Their right hand would now be on your left side because they physically rotated their whole body to look at you. Your brain applies that same mental model to your reflection automatically, unconsciously, instantly, every single time you look in a mirror. But your reflection never rotated. It was never a person turning to face you. There's no rotation happening anywhere in the actual physics. What you're looking at is a depth-reversed version of yourself, not a rotated one, and those are two completely different transformations that happen to produce a confusingly similar-looking result in one specific case. Here's where it gets genuinely elegant. If you actually did rotate 180 degrees physically to stand exactly where your reflection appears to be standing, your right hand would land on the same side as your reflection's apparent left hand. That real rotation is what creates the felt sense of a left-right mismatch. But that rotation happens entirely inside your mind's comparison process. The mirror itself never rotated anything. It only ever reversed depth. This isn't a new observation invented for internet content. Cognitive scientists and philosophers have taken this question seriously for decades. Ned Block published a widely cited paper in 1974 titled directly, "Why Do Mirrors Reverse Right-Left but Not Up-Down?" The question was significant enough to warrant serious academic treatment, not dismissal as a trivial curiosity people argue about at parties. Researchers studying perception have a specific term for this exact mismatch between an object and its mirror image: enantiomorphic confusion. It's been documented and analyzed across psychology and philosophy literature for multiple decades precisely because the confusion turns out to reveal something genuinely interesting about how human perception constructs spatial comparisons. This is where the obvious counterargument shows up, and it deserves a direct answer rather than a dismissal. Hold a piece of paper with writing on it up to a mirror. The letters clearly reverse left to right compared to how you'd read them normally. Doesn't that prove the mirror really does flip left and right after all? It doesn't, and the reason why is worth walking through carefully, because this is exactly the kind of everyday example that keeps the incorrect explanation alive. What's actually happening when you hold text up to a mirror involves two things stacked together: the mirror's depth reversal, plus the specific physical orientation of how you're holding and viewing that piece of paper. You write the text facing yourself. You then flip the paper around to face the mirror so the mirror can reflect it back toward you. That flip, the physical turning of the paper itself, so its printed face points at the glass, is a real rotation, one you performed with your own hands. The mirror then reverses depth on top of that rotation you already introduced, and the combination produces exactly what looks like a horizontal letter reversal. Try it differently, and the illusion evaporates. Write the same text on transparent paper, then look at that text directly through the paper itself, comparing it to the reflected version, without physically flipping anything. The apparent left-right reversal was never a special property the mirror singled out. It was a compound effect created by pairing the mirror's one genuine operation depth reversal with a physical rotation you performed yourself when you turned the page around to face the glass. Water reflections work by this same single-axis principle, with zero exceptions. Camera mirror mode displays on phone selfie screens follow it too. Two-way mirrors used in interrogation rooms and one-way glass follow it. Every flat, reflective surface in the physical universe, regardless of size or material, reverses exactly one axis, the one perpendicular to its surface. There is no material, no coating, no configuration of glass anywhere that reverses left and right as a distinct, targeted operation. The physics has one rule, and it has held unchanged since light first started bouncing off flat surfaces. This single rule traces back much further than modern cognitive science. The law of reflection was rigorously formalized in geometric optics by scholars including Euclid around 300 BCE and refined across centuries of subsequent optical study. The rule itself has never changed in over 2,000 years. What's changed is how clearly anyone bothers to explain it to people who use mirrors every single day without ever examining what they're actually looking at. Here's the failure chain that keeps the wrong explanation alive, across generations worth tracing all the way through. It starts with an assumption baked into human perception itself. Your brain, comparing your body to your reflection, automatically models the reflection as though it physically rotated to face you the way a real person walking around a room would rotate to look at you directly. This isn't a conscious choice. It happens instantly, unconsciously, every time, without any deliberate effort on your part. That imagined rotation, not the mirror's actual optics, is what creates the appearance of a left-right swap. The mirror only ever performed one operation depth reversal, but your brain's automatic comparison process layers an imaginary rotation on top of that single operation, and the combination produces the familiar, confusing left-right mismatch everyone grows up believing is simply how mirrors work. Because this false impression forms so early, so automatically, and so consistently across every single person who has ever looked in a mirror, it becomes embedded in casual language almost immediately. People describe mirrors as flipping left and right the same way they might describe a mirror as reversing color or reversing size, treating it as a plain self-evident property of the glass itself, no different from any other directly observable fact about reflective surfaces. That inaccurate explanation gets passed down through casual conversation, through offhand comments, sometimes even through textbooks that repeat the intuitive but incorrect framing without pausing to test it against a simple counterexample. Nobody questions it because the explanation feels obviously true every single time you glance at your own reflection and see what looks like a swapped hand rising to meet yours. The failure reaches its point of no return the moment someone actually tests the claim against a different axis exactly the way the head tilt experiment does. Lying your head sideways in front of a mirror directly contradicts what the left-right flip theory predicts should happen. If the mirror genuinely singles out left and right as a special targeted operation, tilting your head should produce an up-down swap instead, since you've effectively rotated the axis being compared. It doesn't happen, up stays up, down stays down. The theory fails its own internal logic the instant you actually check it against your own body, proving that depth reversal, not lateral reversal, was the real mechanism all along. The confusion compounds further because of examples like mirrored text, which seem to offer direct, visible proof of horizontal reversal happening right in front of you. Written text reversing on a page held up to a mirror looks like unambiguous evidence supporting the left-right flip framework. In reality, that example is a compound effect combining the mirror's genuine depth reversal with a physical rotation you introduced yourself by turning the paper to face the glass. But because the effect looks so visually convincing, it gets cited again and again as supporting evidence for an explanation that doesn't actually match what's happening, reinforcing the incorrect framework through examples that seem supportive but are actually unrelated to the mirror's real operation. There's something genuinely ironic sitting at the center of this entire puzzle. A mirror is arguably one of the most literal, honest optical devices that exists anywhere. It reflects light according to one unchanging, unambiguous geometric rule, with zero interpretation, zero variability, and zero room for creative license. And yet this same simple, honest device has become the source of one of the most persistently misunderstood everyday physics questions people encounter, repeated confidently by nearly everyone, almost never tested purely because human perception insists on adding an imaginary rotation to a process that never involved any rotation at all. The mirror has never lied about anything. It has been doing the exact same single operation since the first flat reflective surface existed. Your brain has been quietly inventing the confusion the entire time, layering an automatic, unconscious assumption of rotation onto a process that only ever reversed one axis, and doing it so seamlessly that almost nobody notices the substitution happening. Think about a glove turned inside out. Flip a left glove through the correct axis and it becomes usable again as a left glove, oddly enough, not a right one. That's a transformation through one specific dimension, not a simple side swap, and it mirrors exactly the logic driving mirror reflection through the depth axis rather than through left and right. Or consider looking at the back of a printed transparency held up against a light source. The image looks flipped compared to viewing it from the front, but nothing about the printed ink itself moved sideways. You're simply viewing the identical flat image through its opposite face. That's precisely analogous to what a mirror does. It's not sending your image through some sideways specific transformation. It's letting you view a depth-inverted version of the same information, and your mind supplies the rest of the illusion. This principle holds everywhere permanently, with no exceptions written into the physics anywhere. Optical reflection follows one universal, unchanging rule: reversal, along the single axis perpendicular to the reflective surface, regardless of the object's orientation, its size, or whatever cultural framework a given observer uses to describe left and right. Human perceptual assumptions about rotation, not the physics of light itself, are entirely responsible for the everyday confusion, and that distinction applies to any reflective surface in any context for as long as the laws of geometric optics remain accurate. After more than 2,000 years of consistent confirmation, there's no indication that's ever going to change. The next time you catch yourself waving at your own reflection, watch what your brain does in that instant. It will still automatically model the figure in front of you, as though it rotated to face you, and it will still produce that same familiar, slightly uncanny sense of a swapped hand rising to meet yours. Knowing the real mechanism doesn't switch off the illusion. It just reveals clearly that the illusion was never coming from the glass in the first place.